All right, y'all. I just finished watching Level, a Flat Earth film, another documentary put together by Flat Earth researchers. And it made me realize that for over 10 years, or around 10 years, I've been listening to nothing but entertaining arguments from the Flat Earth community and those that question the globe Earth, ball Earth model. And for 10 years, the arguments have been compelling. Observations repeatable, and reasonable questions that have gone unanswered from the scientific community. So, it made me think, okay, let me explore and see what mainstream science is producing these days. What are our top astrophysicists, scientists, what are they saying? What are they doing? What are they sharing with the rest of us? How are they bringing us up to speed with what they claim to have figured out, what they claim to know, that we obviously don't know and understand? I mean, simple example, it's 200 years later, and there's 2-3 definitions on what gravity is. But anyway, so I figured it was a good time for me to go get scienced. Let's hear what Neil deGrasse Tyson is saying these days. I found him. He has got this show called Star Talk, in which him and this other joker sit down and discuss topics in which he chooses to speak on or bring up.
Chuck, we're back.
All right.
I couldn't stay away.
Well, yes.
I got some more explaining to do. So I thought I had some more things to say about the rotation of the Earth.
Really?
Yeah.
Well, we did something about what would happen if it stopped.
We did something about how many people Superman would kill if he
flew backwards and stopped the Earth.
If he flew backwards, slowed down the Earth, stopped it, reversed it, stopped it again, and sent it back. Yeah, nobody left on Earth.
As if that would actually reverse time, though.
Right, as if. Right.
As if.
So even if it did and could, he still killed 7 billion people.
Exactly.
Okay.
I'd like to know how or why the Earth turns in this one, Neil. I'd like to know.
So, here you go. You've heard of this thing called centrifugal force, right? The thing that makes you sort of fly off because somebody spun something around and things fly off.
It's what keeps bucket in the water when you do the whole windmill.
It sounds like you've done some experiments. Good. And if you ever played Matchbox Cars, where the car goes upside down and then comes out the other side, you need sufficient centrifugal force to keep the thing up against the track. Okay? All right. So it turns out there's no such thing as centrifugal force. It's the word we give to this thing that feels like a force operating on you if you are the water in that bucket, or if you're in that amusement park where I think they call it the cyclone, where you're sort of pinned against the wall of it and it rotates and you feel this pressure increase on you. So what's happening is, because you're getting spun, you have an urge to fly off at a tangent of that circle. Okay? That urge to fly off that is prevented, you will feel as a centrifugal force. What that means is, if you're on Earth and Earth is spinning, you ought to feel some centrifugal force.
If you're on Earth and the Earth is spinning, then you should feel some centrifugal force. So far, that makes sense. If I'm spinning on Earth, I should feel something, okay?
Okay. Just like any good amusement park ride. All the equator people.
All the equator people. Yay!
So, now you don't feel that because first Earth connects you to its surface, but also you're moving very uniformly through space to do so. And the air around you is moving with you. So it's not like air is coming past you at 1,000 miles an hour and you feel, oh my gosh, I'm in motion and I feel the jiggle and the shake.
With all the laughing and joking happening in this video, it feels like this is a joke to them. I mean, it sounds like a joke. They're talking about how if you're at the equator, the Earth's spin is 1,000 miles per hour at that point, supposedly. So therefore, they should have their hands up like they're on an amusement park ride. I mean, yeah, it sounds funny because it is. If you're moving at 1,000 miles an hour, you should feel a spin. I'm connected to the ground and everything's moving uniformly. That's how you begin the explanation of me not feeling anything. That's interesting. Go on.
Right.
So ask anybody on an ocean liner, when the ocean liner first pulls out from the port, you don't really notice that.
Because we're moving so smoothly is why we don't feel anything. You're gonna have to do better. You're gonna have to do better than this, Neil. Give me something else, buddy.
Oh, inflate this scenario to the entire Earth.
Okay.
You are moving 1,000 miles an hour as Earth rotates. You are moving 18 miles per second in orbit around the sun, and you don't feel any of that.
So he just slid in there that not only are you moving at 1,000 miles per hour, and you're also moving at 18 miles per second in an orbit system. So not only has he really not explained why you're not feeling movement of 1,000 miles per hour, he hasn't even begun to explain how you're not feeling the movement of 18 miles per second. And he just slid that in there casually, like, yeah, by the way, this is also happening, you don't feel it. But we're gonna stick to this easier topic, which I'm really not gonna explain.
Okay?
Okay.
You don't feel anything. So here's my point. All right? So the faster you rotate,
Okay.
the greater is the centrifugal force that will operate on you. You can ask, if it's trying to fling you off the Earth,
Okay.
but the force of gravity is resisting back, by what force is it trying to fling you off? That upward centrifugal force subtracts from the gravitational force that the Earth is trying to put on you. It subtracts.
The upward centrifugal force subtracts from the gravitational force that the Earth is trying to put on me. This is his explanation for why I don't feel myself moving on Earth at 1,000 miles per hour in a rotation, nor do I feel the 18 miles per second of the orbit motion. And this is his explanation.
Okay.
So Chuck, what do you weigh here and now?
192 pounds. Yeah.
You used to be like 170. So
I used to
what
be
happened?
178,
Yeah.
and now I have a Corona baby that I'm pregnant with.
Corona.
I'm pregnant with a Corona baby.
All right, so then he goes into this whole thing about how people on the equator weigh less there than you would at, let's say, the North Pole. I looked around to see any evidence to support this. I can't say I found anything useful. Then for 2 minutes, they talked about how Santa Claus is going to stay and remain fat because at the North Pole, he's not able to take advantage of this rotational spin weight reduction situation. Are we serious right now? This is what we're doing? So after listening to them talk about weight and fat people, I'm wondering if maybe he brought this up to, because he was thinking about his own weight situation.
Well, watch out, Atkins. There's a new diet coming.
It's a new keto diet.
It's a new keto diet, the super low Earth orbit diet.
Earth orbit diet.
The super low
Again,
Earth orbit
diets
diet.
are so that you lose mass, not that you lose weight.
Oh, yeah,
All right,
that's
just
right.
to make that
I
clear.
keep forgetting.
That's right.
Cool.
Oh, I left out something. Earth is slightly flattened at the poles and slightly wider at the equator. We might have said this on another explainer.
Right.
So we're oblate. We're sort of hamburger shaped rather than prolate, which would be hot dog shaped, stretched pole to pole. We're flattened at the equator. So everyone on the equator is farther away from the center of the Earth than people living on the poles, people and penguins living near the poles. If you're farther away from Earth's center, the force of gravity on you is less. So already their weight is less just because Earth is bulbous at the equator relative to the poles. Then you throw in the rotation on top of it. Folks on the equator got it made in the shade.
Okay, so in here he's talking about the shape of the Earth again. It's been, I think I stopped listening to him completely last time he did this. Once again, he's talking about the oblate spheroid that we supposedly live on. Meanwhile, every picture that NASA has ever given us shows us a sphere ball. But once again, he's talking about not only, before he called it a pear shape. Now it's a hamburger, y'all. So the Earth has gone from the sphere that NASA gives us to this hamburger. This is where we're at. Earth is now a hamburger. He was fat in the beginning. He was talking about fat, Santa Claus, cookies, stuff like that. Now Earth's a hamburger. This mama is hungry, y'all. Oh, shucks. It's been, oh, God, this is where we're at. You know, I came to get scienced, and now I'm just hungry. I want cookies and hamburgers and stuff.
Hot dog shaped stretched pole to pole. We're
And hot dogs.
at the equator, so everyone overtakes it.
I don't even know what to say, man. I was hoping to get some useful perspective on Earth's rotation. I got disappointment.